Okay, so the last piece that I would like to look at in section 13.1 is to use Mathematica to construct parametric plots, and these will plot our space curves. So the particular example I'd like to look at is a space curve defined by parametric equations x equals 4 plus sine 20t all times cosine of t, y equals 4 plus sine 20t all times sine t, and z equals cosine 20t. Now, a couple of things you should notice. In Mathematica, trig functions need to be capitalized and they need to have square brackets around the argument. So, for example, you need capital S for sine of t with square brackets, not sine of t with a lowercase s in parentheses. That won't work. Okay, so let's head over to Mathematica to see how this would work. When you open up Mathematica, I'm going to click on the plus sign and then Mathematica input. There's a palettes, classroom assistant palette that I'm going to bring up as well. And over there in the basic commands, and you can open and close these tabs, basic commands in the 3D tab, click on more. Parametric plot 3D is what we need. Okay, so our x function, let's go back to our PDF of the class notes so we can see what we're doing here. We're going to go parentheses 4 plus sine of 20t. Now if you go up here to the advanced tab and click on sine, notice that Mathematica will type it in with a capital S and the square brackets. We need 20 times t. If you type in a lowercase sign, it will not work. All right. End parentheses times cosine t. Next component is our y function. So we've got parentheses 4 plus sine 20 times t. End parentheses times sine t. And lastly, for the z function, we need cosine square bracket 20 times t. Let's let t go from 0 to pi, and you could type pi in with a capital Pi, or you could go over to the Classroom Assistant palette and choose the pi symbol. To execute this code, let's hit Shift Enter. I'm going to make this bigger. So that was pretty cool. We actually have a beautiful space curve. Now, it would be interesting to see what happens if we let t go from 0 to 2 pi. And the reason why 2 pi is a really good choice here is because these cosine and sine functions, to go through a full period of them, we really need to go from 0 to 2 pi. Going 0 to pi is only like half of the deal, so we really need to extend that domain for t. And sure enough, we get this beautiful space curve. Now you could try letting this go to 6 pi or something. Maybe we will even get more interesting behavior, and it didn't change our plot at all. So this is a periodic function. It repeats over itself. We really overdid it with the 6 pi. Only 2 pi was required to get the whole curve. I would encourage you to do some other plots and to use this as you work through your homework.